Okay, question number 1 for day 10. It says, using the graph, make a claim. What is the relationship between mass and kinetic energy? So we have our graph down here, and I put the definition for both kinetic and potential energy for you guys. And then we have our answer choices. It looks like the answer choices are giving us our claim. It says, as mass of the object decreases, then kinetic energy of the object increases. As the mass of the object increases, the kinetic energy of the object decreases. And so we're just trying to pick exactly what we see happening in the graph. If you wanted to go through each answer choice and see if it's kind of true or false, you could do that. Or we could just do it right here really quickly. And then you can just choose which answer choice works best. So I will show you guys exactly what's happening. Okay. I'll just do red. Okay, so we have our IV over here, which is labeled or mentioned first. As mass does something, what happens to kinetic energy? So we already see that on our graph. Is mass increasing over time or decreasing? It's going from 1 to 10, so that's an increase. So our IV over time is increasing. So you already know from your answer choices down here at the bottom, you're looking for the one, which I think there's 2 options. I can't scroll right now. Here, actually, I can go like this. 2 options as the mass increases, and then here's another one as the mass increases. So we already know right off the bat that it's going to be one of those, because that's our only option in our graph. Now I need to decide what is happening to kinetic energy as our mass is increasing. Kinetic energy is our dependent variable, because that's what we were measuring every single time we changed the mass of that object. Now, we started at 1, and our kinetic energy was 2. Increased our mass to 2, kinetic energy went to 4. You can already see what happened there. It increased. Now, mass, we went from 2 to looks like 5. At 5, our kinetic energy is 10. And so us increasing our mass from 2 to 5 increased our kinetic energy from 4 to 10. Now, there's some questions at the bottom that are going to talk to you about, let's see, this last question says, or this last sentence says, the student also ran the simulation with a fourth mass of 8 kilograms, which isn't shown on the graph. Here's 8 right down here, which I'll change that to red, that way we can see that it's our IV. And we kind of have to make a prediction, which I'm going to do the prediction with you guys right now, because also in the next question, question number 2, you have to predict what it would be at 10, I believe. Isn't that what it had? No, number 3. Number 3 asks you for number 4. There we go. Number 4 asks you to predict what kinetic energy could be at 10 grams. So I'm going to show you what it could be at 8 kilograms. 8 kilograms right here. This is kind of like a line of best fit. And so if we just follow exactly what we're already seeing right here happening and keep going straight up from the ones that we already had, we can kind of meet, let's see, where's 8? 8 is about right there. So I would say if we changed our mass to 8 kilograms, somewhere between here and here would be our projected kinetic energy. It actually hits right there, which would be about 15. So I did 8 with you guys. Remember, on number 4, you're going to come back and watch this video, and you can decide what 10 would be.